A day is longer than a year. Did I say something wrong? Well, technically no. In certain conditions, it is possible. But before we go there, you and I need to agree on something simple. A day is always shorter than a year, right? That's basic. A year is longer than a day. Every one of us growing up knowing that. Fundamental, unshakable, you and I agree. But what if I told you that in our own solar system, a day can be longer than a year? And I don't want you to just take my word for it. I want you to question it with me. First, we need to define what a day even is. We think of a day as a universal constant, 24 hours. But in physics, there are actually two ways you can measure a day, and they don't match. First, there is a sidereal day, how long a planet takes to spin exactly 360 degrees on its axis. On Earth, that's 23 hours and 56 minutes. And then there is a solar day. That's how long it takes for the sun to return to the same position in the sky. Because Earth is moving along its orbit while it spins, it has to rotate just a little bit extra to find the sun again. And that takes an extra 4 minutes. Total 24 hours. So on Earth, the sidereal day is 23 hours and 56 minutes, while the solar day is 24 hours. As you probably have guessed it already, it's the solar day we'll live our lives by, the rhythm of the sun, not the spin of the planet. When Earth goes around the sun once, and that full orbit takes about 365 solar days, and the 365 days we call 1 year. But Earth doesn't exactly take 365 days. It actually takes 365.2422 days. And that extra 24, basically a quarter of a day, is why we add one extra day every 4 years. And that explains a lot about a calendar and time, because that's what gives us a leap year. So a day is short and a year is long, at least on Earth. But on Venus, things get a little tricky. On Venus, you celebrate your first birthday before you even see the sunset for the first time in your life, because it takes Venus 243 Earth days to spin once, but only 225 Earth days to orbit the Sun. So, by the time Venus has finished 1 year, it hasn't finished one rotation. Meaning, a day on Venus lasts longer than its entire year. Imagine celebrating New Year's, and by the time the next one arrives, your planet hasn't finished a single rotation. And that's Venus. It bends one of the most basic rules we thought was universal. But it gets weirder. This is where we hit the solar day paradox. Things get strange. Most planets spin the same direction they orbit, but Venus spins backward. So the sun actually returns to the same spot in the sky faster than the planet completes a full rotation. So even though it takes 243 days to spin once, the sun actually rises and sets every 117 Earth days. So on Venus, the sidereal day, the rotation, is longer than the year. But the solar day, the daylight cycle, is shorter than the year. And that brings us to a real question. Why is it spinning so slowly and the wrong way in the first place? But it gets weirder. Nearly every planet in our solar systems spins counterclockwise. But Venus, it's a rebel. It spins clockwise, what we call retrograde rotation. If you could stand on its surface, you would watch the sun rise in the west and set in the east. But why? Scientists aren't exactly sure. They think something violent happened early in the solar system, maybe a massive collision that knocked the planet off balance. But it doesn't tell us why it is a slow rotation. Most planets close to the star eventually becomes tidally locked. One side always faces the star, while the other never sees it. Our moon is a very good example. Even though Earth isn't a star, the same gravitational effect applies, which is why the moon always shows the same face to us. This happens because the more massive objects the star or planet pulls on the other world with its gravity. That pull creates a small bulge. Over time, the constant tug of that bulge slows the planet's rotation until the same side always faces the star. This happens because the more massive body, like a star or a planet, pulls more strongly on a smaller object, gradually slowing its spin until the same side always faces it. But Venus is different. It is a rebel. Venus is not tightly locked. But why? The answer lies in its atmosphere. Venus has an atmosphere about 90 times thicker than Earth's. It's so dense that in many ways it behaves almost like a slow-moving ocean of air. As the sun heats this massive atmosphere, it creates this atmospheric tides. Those tides push against the planet's rotation. This atmospheric drag acts like a brake. It is strong enough to fight back the sun's gravity, stopping Venus from being locked into this permanent face-off with its star. So, for billions of years, two forces have been competing: the sun's gravity trying to lock Venus in its place, and Venus' atmosphere pushing back like a rebel. A cosmic tug of war that has been going on for more than 4 billion years. And so far, neither side has fully won. But it gets even more weirder. And here is the part that really bends your mind. The surface of Venus crawls along at just 6 kilometers per hour. But the clouds high above it races around the entire planet at nearly 360 kilometers per hour. This phenomenon is called superrotation. The atmosphere completes a full lap around Venus in just 4 days, even though the planet itself takes 243 days to rotate. We still don't fully understand how it manages to keep that speed. But if you were floating in a balloon inside those clouds, your day would last only 96 hours. But down on the ground though, one Venus day takes 243 Earth days to pass, longer than an entire Venus year. Before we end, here are a few more strange things about Venus. Venus is one of those planets where logic almost seems to give up. It rains there, but the rain never reaches the ground. The droplets evaporate while falling through the scorching atmosphere. Scientists call this phenomenon Virga. And on the highest mountain peak, something even stranger happens. It actually snows metal, not water, not ice, a thin metallic frost made from compound of lead and bismuth settling over entire mountain tops. Just imagine that for a moment, a planet where rain disappears before touching the ground and mountains are dusted with metals instead of snow. Venus truly is one of the strangest worlds in our solar system. And thank you for spending these few minutes with me, my friend. If you enjoyed this video, please consider subscribing. I truly appreciate the support. And don't miss the echo verses at the end of this video. Thank you. A random shout out to our community members to show my appreciation for your support. Thank you. We grow up anchored to what we believe are absolutes. Some are true laws of nature, others are just averages. We are grown used to. Even the most basic truth feels unshakable, like the beliefs that a day must be shorter than a year. But today we saw on Venus that truth falls apart. Life is no different, my friend. The same sun that melts the winter snow is the same sun that hardens the clay to stone. The light is identical, the heat is the same, yet the outcome and the destiny of those atoms is transformed. Maybe life works like that too. Sometimes you are the clay finding your strength within the fire, and sometimes you are the snow, soft enough to melt with warmth and kindness. Your life was never meant to be a ghost of someone else's path. You're not an average. You are not a data point. You're something singular. The cosmos reveals a secret. The rules of the many have no dominion over the one. Perhaps you were never built to match an exception. Perhaps you were built to be the exception. The universe shows us that certainty is often just a habit of the mind. You are not a habit. You are the glitch in the matrix. Some may call the anomaly Neo, but I know, my friend, it's you.